Hello and welcome back to Midnight Sleep Scientist, a gentle harbour where vast questions drift on quiet currents and nothing urgent disturbs the calm. If you're settling into the cool embrace of evening, letting the day's tensions slide from your shoulders like water from glass, you're already practicing the science that matters most tonight. Breathing in, breathing out, no rush at all. Our tender question tonight is one that beckons from the edge of imagination. Are black holes doorways to other universes? Not a declaration, just a whisper in the dark. A candle flame casting dancing shadows on the wall, not a searchlight demanding answers. Picture a moonless night that doesn't feel empty, only expectant. Far above, the stars keep their patient vigil, and somewhere among them, black holes turn in their silent dance, regions where space and time bend so deeply that even light cannot find its way home. We usually think of black holes as endings, as cosmic full stops where stories cease. But tonight, we'll explore a gentler possibility. What if they are not periods but semicolons? What if the deepest darkness conceals not an ending but a doorway? What if what appears to be a cosmic grave is actually a cosmic birth canal, a passage through which entire universes might slip into being? Now breathe again, slow and steady. Let your jaw unclench if it needs to. Nothing sharp approaches. To wonder whether black holes might be doorways is to ask whether the most mysterious objects in our universe might also be the most generous, offering not just destruction but creation, not just an ending but a beginning disguised as an ending. The word doorway itself carries warmth. Doorways are thresholds, places of transition and possibility. They separate one room from another, while also connecting them. A doorway implies that there is somewhere to go, something beyond. In our cosmic context, a doorway suggests that the universe might be more like a house, with many rooms than a single chamber with locked walls. Let's promise each other something gentle. As we begin this journey, we'll walk softly through ideas that push at the edges of what we think we know. We'll use words like perhaps and might, because the night prefers honesty to certainty. We won't rush toward conclusions, but will meander like streams, finding their way to the sea, letting each idea flow naturally into the next. If you find yourself drifting towards sleep along the way, that's perfectly welcome. The questions will hold their place in the darkness, patient as old trees, waiting for your return. And if you remain awake to the end and feel moved to share, tell me where you're listening from tonight. Our quiet constellation of listeners grows brighter with each gentle voice. For now, hold this image, a vast cosmic garden at midnight. In the distance, barely visible against the star-scattered darkness, stand what appear to be monuments of shadow, tall and silent. But as you watch with patient eyes, you begin to suspect that these dark sentinels are not monuments at all, but gateways, and beyond each gateway, impossibly stretches another garden, another night sky, another infinite expanse of possibility. Tonight, we'll learn whether this vision might be more than poetry. Let's begin where all cosmic stories must, with the tender laws that govern how matter and energy dance through space-time. Breathe deeply, and let's approach black holes not as fearsome cosmic monsters, but as the universe's most elegant architectural achievements. Picture space-time as a vast soft fabric, stretched taut beneath the stars. This fabric is not empty stage dressing. It is the very medium in which existence unfolds. When we place objects upon this fabric, a star, a planet, even a grain of dust, the fabric dimples and curves around them. The more massive the object, the deeper the curve it creates in the cosmic cloth. In Einstein's gentle revolution, gravity is not a force that reaches out and grabs, but a landscape that guides. Objects don't fall because they are pulled. They follow the most natural paths available to them, and those paths curve when mass tells space-time how to bend. It's like watching a marble roll across a curved surface. The marble isn't being dragged by invisible strings. It's simply following the shape of the world beneath it. A black hole represents the deepest possible curve in this fabric, a depression so profound that it creates what we might call a cosmic waterfall. Once matter crosses a certain threshold, the event horizon, every possible path leads inexorably inward, toward the center. It's not that escape becomes difficult, it becomes geometrically impossible. The very definition of outward ceases to exist. But let's soften the harsh edges of this description. The event horizon is not a wall or a membrane. You could pass through it without feeling any barrier, any resistance. It's more like crossing an invisible line on a hillside. Only after you've crossed it do you realize that every step forward now carries you inevitably downhill. The horizon is a point of no return, but the return it forbids is subtle, written into the geometry itself rather than enforced by any physical barrier. Imagine standing at the edge of a vast, gentle whirlpool in perfectly clear water. Far from the center, you can easily swim in any direction, even directly away from the whirlpool's heart. But as you move closer to the center, you notice that maintaining your position requires more and more effort. Closer still, and you find that no matter which direction you try to swim, the current carries you inexorably inward. There is no violence here, no sudden grabbing or pulling, only the patient, implacable geometry of flow. This is the secret that transforms our understanding of black holes from cosmic horror to cosmic architecture. The event horizon is not a trapdoor that opens suddenly beneath the unwary. It's a region where the very meaning of direction undergoes a subtle transformation. Inside the horizon, what was once the spatial direction outward becomes something more like the temporal direction future. The center of the black hole doesn't lie in some distant place you might choose to visit. It lies in your future, as inevitable as tomorrow. From far away, watching matter fall toward a black hole creates a beautiful and strange paradox. The falling material appears to slow down as it approaches the horizon, its light stretching to longer and longer wavelengths, reddening like a sunset that never quite ends. Time itself seems to dilate, stretching each second into an eternity. To the distant observer, the matter appears to freeze at the horizon, dimming slowly until it fades from view entirely. But from the perspective of the falling matter itself, nothing strange happens at the horizon. Time flows normally, seconds tick by at their usual pace, and the passage through the event horizon feels no different from crossing any other invisible line in space. It's only later, when you try to send a message back to the outside world, that you discover the profound asymmetry built into the black hole's architecture. Messages can flow inward across the horizon, but nothing, not matter, not energy, not information, can flow back out. Let's take a gentle tour of the different kinds of black holes that populate our cosmic garden. The most common are stellar mass black holes, typically containing 10 to 50 times the mass of our Sun. These form when massive stars, having exhausted their nuclear fuel, can no longer maintain the outward pressure needed to balance their own gravitational pull. The star's core collapses in a catastrophic implosion, creating a region so dense that escape becomes impossible. But stars are not the only architects of black holes. At the centers of most galaxies, including our own Milky Way, lurk supermassive black holes containing millions or billions of times the mass of the Sun. How these giants formed remains one of astronomy's most intriguing mysteries. Perhaps they grew from smaller seeds over cosmic time, gradually accumulating matter like cosmic snowballs. Or perhaps they formed directly from the collapse of massive gas clouds in the early universe, when the cosmic web was still taking shape. Between these extremes lies a hypothetical middle ground, intermediate mass black holes, containing hundreds or thousands of solar masses. These remain largely theoretical, their existence inferred rather than directly observed. They would represent a middle chapter in the story of black hole formation, bridging the gap between stellar death and galactic assembly. The geometry of rotating black holes adds layers of complexity to our cosmic architecture. When a black hole spins, and most do inheriting angular momentum from their parent stars or accretion processes, the space-time around them becomes twisted, dragged along by the rotation, like honey stirred in a jar. This creates a region called the ergosphere, where space-time itself is pulled along with the black hole's rotation, so strongly that nothing can remain stationary relative to distant observers. Think of this as a cosmic whirlpool, where the water itself is rotating. Far from the center, you might be able to swim against the current and maintain your position, but closer to the rotating mass, you find yourself inevitably swept along, even if you're not trying to move. The ergosphere is the region where this cosmic dragging becomes inescapable. Inside the ergosphere, but outside the event horizon, strange possibilities emerge. Matter can actually extract energy from the black hole's rotation, stealing some of its angular momentum and emerging with more energy than it initially possessed. This process, known as the Penrose mechanism, transforms black holes from mere cosmic drains into potential engines of creation, capable of powering some of the most energetic phenomena in the universe. What lies at the heart of a black hole? Classical physics suggests a singularity, a point where density becomes infinite and the normal laws of physics break down. But singularities in physics are often signs that our theories have reached their limits, rather than descriptions of physical reality. Just as the rainbow appears to end at a sharp point when viewed from afar, but reveals itself as light and mist when approached more closely, the singularity at a black hole's center may be a mirage created by the limitations of our current understanding. Modern theories that attempt to merge quantum mechanics with general relativity suggest that the singularity might be resolved into something less dramatic, perhaps a region where space and time take on new properties, where the familiar concepts of here and now dissolve into something more fundamental. These quantum theories hint that the center of a black hole might not be an end, but a beginning, not a point of destruction, but a seed of creation. This brings us to the gentle heart of tonight's question. If the center of a black hole is not a singularity, but something more subtle, perhaps a gateway, a transition point, a doorway, then what might lie beyond that doorway? Could it be that what appears from the outside as the ultimate ending is actually from another perspective, a cosmic beginning? Now breathe deeply and let this possibility settle gently in your mind like snow falling on a quiet landscape. The architecture of black holes, with their event horizons and ergospheres, their subtle geometries and hidden hearts, may be far stranger and more wonderful than we have yet imagined. What we have learned to see as cosmic graveyards might instead be cosmic nurseries, tending to the birth of new worlds we cannot yet perceive. Let your shoulders drop a little further. Feel the day's tensions continue to dissolve. We've begun our journey into the possibility that black holes are not endpoints, but doorways, not periods, but ellipses, suggesting continuation beyond the visible page. In our next chapter, we'll explore what might lie beyond those doorways, and how entire universes might slip through the fabric of space-time, like seeds through cosmic soil. Another breath, soft and easy. Let your body sink a little deeper into comfort as we cross the threshold from what we know into what we can only dream. Tonight, we wade gently into the vast ocean of possibility called the multiverse, not as a destination we can visit, but as a landscape we can explore with careful thought and tender imagination. The word multiverse carries within it both promise and vertigo. It suggests that our universe, vast as it seems to us, might be only one garden in an infinite botanical preserve, one song in an endless symphony, one chapter in a library whose shelves stretch beyond the reach of any single reader. But let's approach this overwhelming possibility with the same gentleness we bring to all midnight contemplations. Begin with the simplest version of the multiverse concept, sometimes called the observable universe boundary idea. We know that our view of the cosmos is limited by the distance light has traveled since the universe began its current expansion phase. Beyond this cosmic horizon lies more space, more galaxies, more of the same cosmic fabric extending perhaps infinitely in all directions. This isn't really a multiverse in the dramatic sense. It's more like standing in a vast library and recognizing that there are more books beyond the ones you can see from where you stand. But the multiverse concept that captures imaginations and midnight wanderings goes much deeper. It suggests that there might be entirely separate realms of existence, regions of space and time that operate according to different rules, different physical constants, different possibilities. These wouldn't simply be distant parts of our own cosmic tapestry, but entirely separate tapestries woven from different threads. One path to this possibility emerges from quantum mechanics, the most mysterious and successful theory in all of physics. Quantum mechanics tells us that at the smallest scales, reality is fundamentally probabilistic. When a quantum system is measured or observed, it appears to choose one outcome from among many possibilities. But what happens to the other possibilities? The paths not taken? The many worlds interpretation of quantum mechanics offers a breathtaking answer. Perhaps all possibilities are realized, but in separate universes, each quantum measurement, each moment of apparent chance or choice, causes reality to branch, like a river delta. In one branch, the electron spins up, in another it spins down. In one branch, the radioactive atom decays, in another it remains intact. Every possible outcome of every quantum event occurs somewhere in the vast branching tree of reality. This quantum multiverse would be infinite, not just in space, but in possibility. Every decision you've ever made, every path you've chosen or avoided, every moment of chance that shaped your life, all of these would exist somewhere in the infinite garden of parallel worlds. There would be universes where dinosaurs never went extinct, where you chose a different career, where the Library of Alexandria never burned, where the laws of physics themselves evolved along different paths. But quantum branching is just one pathway to the multiverse. Cosmology offers another, perhaps even more dramatic possibility. Some theories suggest that our universe's expansion and cooling might not be a unique event, but part of a larger process called eternal inflation. In this picture, space itself is constantly expanding and spawning new regions, new universes, new cosmic bubbles in an endless, self-reproducing foam of space-time. Imagine blowing soap bubbles on a cosmic scale. Each bubble represents a universe with its own physical laws, its own particles, its own fundamental constants. Some bubbles might be similar to ours, containing galaxies and stars, and the possibility of life. Others might be radically different, universes where gravity is stronger or weaker, where different particles exist, where time itself flows differently or perhaps not at all. This eternal inflation multiverse would be vast beyond comprehension, with new universes constantly budding off from older ones, creating an ever-expanding tree of cosmic possibility. Our own universe would be just one bubble in this infinite foam, and we would have no direct way of detecting or communicating with the other bubbles that surround us in the larger space-time. There's also the possibility of what physicists call brain worlds, universe-sized membranes floating in higher dimensional space, like sheets of paper scattered through a vast three-dimensional room. In this picture, what we experience as our three-dimensional space plus time might be just the surface of a higher dimensional object. Other brains, other universe sheets, might be floating nearby in dimensions we cannot perceive, close enough to touch, but forever invisible to our senses. These brain universes might occasionally interact, brushing against each other in cosmic collisions that could leave detectable traces in our cosmic microwave background radiation. They might even explain some of the mysteries of our own universe. Dark matter, for instance, might be ordinary matter trapped on a nearby brain, close enough to exert gravitational influence on our world, but forever invisible to our eyes. But perhaps the most poetic version of the multiverse emerges from string theory, that ambitious attempt to unify all forces and particles into a single, elegant framework. String theory suggests that the fundamental building blocks of reality are not point-like particles, but tiny vibrating strings, and the different ways these strings can vibrate give rise to all the particles and forces we observe. But string theory also suggests that there might be many different ways to configure the extra dimensions that the theory requires, perhaps as many as 10,500 different configurations, a number so vast that it dwarfs even our most generous estimates of the number of atoms in our observable universe. Each configuration would represent a different possible universe with its own unique physics, its own particles, its own laws. This string theory landscape would be a vast ecosystem of possible universes, some hospitable to complexity and life, others barren and empty. Still others governed by physics so alien that we cannot even imagine what forms of existence they might support. Our universe would be one small garden plot in this infinite landscape of possibility. Now let's breathe gently and consider how this multiverse tapestry might connect to our central question about black holes as doorways. If multiple universes exist, and if black holes can serve as passages between different regions of space-time, then perhaps black holes are not just doorways within our own universe, but gateways to entirely different universes, portals through which matter and energy might slip from one cosmic realm to another. This possibility takes many forms in the careful speculations of theoretical physicists. Perhaps when matter falls through a black hole's event horizon, it doesn't reach a singularity at all, but instead emerges in another universe, possibly through what would appear to observers there as a white hole, a region from which matter and energy spontaneously emerge rather than disappear. Or perhaps the process is more subtle. Perhaps the information that defines the fallen matter, its quantum properties, its energy, its organizational patterns, is somehow encoded on the black hole's event horizon, and then transmitted to another universe through processes we don't yet understand. In this view, black holes might be cosmic copying machines, preserving the essential information of our universe while simultaneously seeding other universes with new possibilities for complexity and structure. Some theories even suggest that our own universe might have emerged from a black hole in a parent universe, making our cosmic beginning not a creation from nothing but a birth from something else, a budding off from an older, larger cosmic tree. In this picture, every black hole in our universe might be pregnant with the possibility of giving birth to new universes, making the cosmos not just a garden, but a garden that constantly plants new seeds of existence. The mathematics behind these ideas is complex and still largely speculative, but the underlying concept is beautifully simple. If space and time can be curved and twisted by mass and energy, if horizons can hide regions from which no information can escape, then perhaps these same geometrical possibilities that create black holes might also create passages to entirely new realms of existence. Consider the topology, the shape and connection properties of space-time itself. We're accustomed to thinking of space as having a simple, flat topology on large scales, like the surface of a vast table, but general relativity allows for much more complex topologies, including what mathematicians call wormholes, tunnel-like connections between distant regions of space, or even between entirely separate spaces. A wormhole would be like a cosmic subway tunnel, allowing travel between regions that are far apart in normal space, but connected by a shortcut through higher dimensional space-time. The entrance to such a wormhole might look very much like a black hole, a region where space curves so extremely that normal intuitions about distance and direction break down. But unlike black holes, wormholes might be traversable. At least in principle, matter and information could enter one end and emerge at the other, potentially in a completely different universe. The challenge is that most theoretical wormholes are unstable, collapsing before anything could pass through them, like tunnels dug in sand that cave in the moment you try to crawl through. However, some theories suggest that certain quantum effects or exotic forms of matter might stabilize wormholes, keeping them open long enough for matter and energy to flow through. If such stable wormholes exist, and if they can be created by the same processes that create black holes, then every black hole might potentially be a gateway to adventure, a doorway to realms beyond our current imagination. Let your mind rest for a moment in this possibility. Picture the cosmic landscape not as a single garden, but as an infinite network of gardens, connected by secret pathways that we call black holes. Matter falls into a black hole in our universe, and emerges as the raw material for new galaxies, new stars, new possibilities for complexity and wonder in another cosmic realm. The death of one star becomes the seed for entire universes elsewhere. This vision transforms our understanding of cosmic purpose and meaning. Instead of being a universe slowly winding down toward heat, death, we might be part of an eternally creative multiverse, constantly giving birth to new realms through the dark portals we call black holes. Every stellar collapse, every galactic merger, every feeding supermassive black hole might be participating in an endless cycle of cosmic reproduction, ensuring that complexity and possibility never truly end, but are constantly reborn in new forms. As you sink deeper into comfortable rest, let this image accompany you. A vast cosmic web where black holes are not endpoints, but nodes, connecting points in an infinite network of possibility through these dark doorways. The substance of our universe flows outward to seed new realms, while perhaps the substance of other universes flows inward to enrich our own cosmic garden. We are not alone in existence, but part of a vast community of universes, each contributing to the other's growth and evolution through the patient, mysterious work of black holes. In our next chapter, we'll explore the evidence, both theoretical and observational, that might support this magnificent vision of black holes as cosmic doorways. Science advances not through sudden revelations, but through patient accumulation of evidence, like dew forming drop by drop on morning grass. The question of whether black holes are doorways to other universes sits at the very edge of what current physics can address. where theoretical possibility meets observational mystery, where mathematical beauty encounters the stubborn resistance of experimental proof. Settle a little deeper into the night's embrace. Let your breathing slow to match the gentle rhythm of our exploration. We've wandered through the architecture of black holes and glimpsed the infinite garden of the multiverse. Now comes the careful work of listening for whispers, the subtle clues that might suggest whether black holes truly serve as doorways to other universes, or whether this remains a beautiful dream waiting for awakening. Let's begin with the gentlest clues, the theoretical foundations that make black hole doorways. Not just possible, but almost inevitable, given our current understanding of physics. The first comes from the fundamental symmetries of general relativity itself. Einstein's equations describe how mass and energy curve space-time, but they are remarkably democratic in their treatment of time. The equations work equally well whether time flows forward or backward, creating a deep symmetry in the mathematical description of reality. This time reversal symmetry suggests that, if black holes can exist, regions where matter falls inward and cannot escape, then their time-reversed cousins, white holes, should also be possible. White holes would be regions from which matter and energy emerge spontaneously, unable to receive anything from the outside. While we have never observed a white hole in our universe, the mathematics insists they should be possible. Now here's where the doorway possibility becomes intriguing. Some solutions to Einstein's equations suggest that black holes and white holes might be connected, two mouths of the same cosmic tunnel. Matter falling into a black hole might not reach a singularity, but instead emerge from a white hole, possibly in another region of space, or even in another universe entirely. The black hole serves as an entrance, the white hole as an exit, and the connection between them as the doorway itself. These mathematical structures, called Einstein-Rosen bridges or wormholes, are solutions to the field equations that describe tunnel-like connections through space-time. Picture space-time as a sheet of paper, and imagine folding the paper so that two distant points touch. A wormhole would be like poking a pencil through both layers at once, creating a shortcut between regions that would otherwise be separated by vast distances. But mathematics and physical reality don't always align perfectly. Most theoretical wormholes suffer from a fatal flaw. They are unstable, collapsing so quickly that nothing could pass through them. It's like trying to crawl through a tunnel made of dry sand. The moment you enter, the walls cave in and seal the passage. However, some theoretical physicists have found ways around this problem. If certain exotic forms of matter exist, matter with negative energy density or unusual pressure properties, they might serve as cosmic scaffolding, propping open wormhole tunnels and making them traversable. These exotic matter requirements are extreme, involving physics that we don't yet understand, and energy conditions that seem to violate our everyday experience. But the universe has surprised us before, with phenomena that seemed impossible until we observed them. Dark matter, dark energy, quantum entanglement, all of these were once considered exotic or impossible, yet they now form the foundation of our standard cosmological model. Perhaps the exotic matter needed to stabilize wormholes will prove no more impossible than these other mysterious components of reality. The quantum mechanical picture adds another layer of whispered evidence. In quantum mechanics, the vacuum of space is not empty, but filled with quantum fluctuations, virtual particles that appear and disappear in accordance with Heisenberg's uncertainty principle. These quantum effects become extremely important near black hole horizons, where the extreme curvature of space-time amplifies their influence. But Hawking radiation raises a profound puzzle known as the information paradox. If black holes evaporate completely, what happens to the information that fell into them? The quantum mechanical principle of information conservation suggests that information cannot be destroyed. Yet if the black hole disappears entirely, the information it contained seems to vanish with it. Stephen Hawking's famous insight about black hole radiation emerges from these quantum effects near the horizon. Pairs of virtual particles, normally destined to annihilate each other, can be separated by the black hole's gravitational field. One particle falls across the horizon while its partner escapes into space as real radiation. This process, known as Hawking radiation, causes black holes to slowly evaporate over vast timescales. Recent developments in theoretical physics have provided additional whispers of evidence. The holographic principle, emerging from string theory and black hole thermodynamics, suggests that all the information contained within a volume of space might be encoded on its boundary surface. For black holes, this means that all the information about the matter that fell in might be stored on the event horizon itself, like a cosmic hard drive. If the holographic principle is correct, then black hole horizons are not simple boundaries, but complex information storage and processing systems. They might serve as cosmic rotors, encoding the information of infalling matter and transmitting it through higher dimensional channels to other universes. The black hole becomes not just a doorway but a communications hub, facilitating the exchange of information across cosmic realms. One resolution to this paradox suggests that the information is not destroyed but transferred elsewhere, perhaps to another universe through the doorway mechanism we've been exploring. In this view, when matter falls into a black hole, its information is encoded and transmitted through the wormhole connection to emerge in another cosmic realm. The information is conserved, but in a location we cannot directly access or observe. The mathematics of string theory also suggests the existence of extra spatial dimensions beyond the three we experience directly. If other universes exist as separate regions in these higher dimensional spaces, then black holes might serve as gravitational bridges, connecting our three-dimensional space to other three-dimensional spaces embedded in the larger dimensional framework. String theory provides its own set of whispered clues. In string theory's mathematical landscape, black holes are not simple objects but complex dynamical systems with internal structure. Some string theory models suggest that what appears from the outside as a black hole might actually be a highly excited string state, a tangle of fundamental strings vibrating in complex patterns. These excited string states might have the capacity to transform, to tunnel from one configuration to another through quantum mechanical processes. If one of these configurations corresponds to our universe and another to a different universe, then the black hole's internal string dynamics might facilitate matter and information transfer between cosmic realms. The cosmic microwave background radiation, that ancient afterglow of the universe's hot early phase, might also carry whispers of evidence. If our universe emerged from a black hole in a parent universe, this birth process might have left subtle imprints in the pattern of temperature fluctuations across the sky. These imprints would be like fossil evidence of our cosmic origins, frozen into the oldest light we can observe. Now let's turn to the observational whispers, the subtle clues that might be detectable with current or future instruments. The first comes from gravitational wave astronomy, our newest window into the cosmos. When black holes merge, they create ripples in space-time that travel outward at the speed of light, carrying information about the collision encoded in the pattern of gravitational waves. Some theoretical models predict that if black holes are connected to other universes, the merger process might produce distinctive gravitational wave signatures. The waves might carry subtle echoes or modulations that reflect the influence of the other universe on the merger dynamics. These signatures would be incredibly subtle, requiring extremely sensitive analysis to detect, but they might be observable with future generations of gravitational wave detectors. Current observations of the cosmic microwave background do show some puzzling anomalies. The cold spot, the alignment of large-scale temperature patterns, the suppression of power at the largest angular scales. While these anomalies might have conventional explanations, they could also be whispers of our universe's exotic birth through a black hole doorway. Some cosmological models predict that a universe born from a black hole would begin with slightly different initial conditions than a universe born from a traditional Big Bang. These differences might manifest as statistical anomalies in the cosmic microwave background, subtle deviations from the patterns predicted by standard cosmological models. Another observational whisper comes from the study of black hole jets. Many black holes, particularly supermassive ones at galaxy centers, produce narrow beams of high-energy particles that stream outward at nearly the speed of light. These jets are powered by matter falling into the black hole, but the exact mechanism remains mysterious. If black holes are connected to other universes, the jet formation process might involve more than just local physics. Perhaps some of the energy that appears to be lost when matter crosses the event horizon is actually transferred to the other universe, and the jets represent a kind of energy return, a balancing of accounts between cosmic realms. Subtle features in jet behavior, their variability, their energy distribution, their magnetic field structures, might carry signatures of this trans-universal energy exchange. The phenomenon of dark matter also provides whispered hints. Dark matter makes up roughly 27% of the universe's energy budget, yet it interacts so weakly with ordinary matter that we can detect it only through its gravitational effects. One speculative possibility is that dark matter particles are actually ordinary matter from other universes, leaking through black hole doorways into our cosmic realm. If this were true, then the distribution of dark matter around galaxies might carry information about the distribution of matter in other universes. The cosmic web of dark matter that scaffolds galaxy formation might be a shadow cast by the structure of other cosmic realms, transmitted to us through the network of black hole doorways that connect the multiverse. The absence of evidence can also be informative. If black holes were efficient doorways to other universes, we might expect to see certain phenomena that we don't observe. For instance, we might expect to see matter or energy appearing spontaneously in our universe, emerging from white hole counterparts to black holes in other universes. The fact that we don't observe such phenomena places constraints on how the doorway mechanism might work. Even more speculatively, some physicists have suggested that the accelerating expansion of our universe, driven by mysterious dark energy, might be connected to the multiverse doorway mechanism. Perhaps dark energy represents a kind of pressure from other universes, transmitted through black hole connections and manifest in our universe as a repulsive force that drives cosmic acceleration. These observational whispers are subtle and speculative, requiring careful analysis and multiple independent confirmations before they could be considered strong evidence. But they illustrate how the doorway hypothesis might eventually be tested, how theoretical speculation might eventually meet observational reality. Perhaps we are not alone in a single universe, but part of a vast community of cosmic realms, connected by black hole doorways that allow the patient exchange of matter, energy, and information across unimaginable scales. Perhaps every stellar collapse, every galactic merger, every feeding black hole is participating in a cosmic conversation we are only beginning to learn how to hear. Let your mind rest gently with these whispers of evidence. Like astronomers studying faint stars at the edge of vision, we are listening for signals that are barely above the noise, seeking patterns that might reveal the presence of cosmic doorways. The evidence is subtle, speculative, and incomplete, but it points toward possibilities that are both magnificent and humbling. Similarly, if information and energy were freely flowing between universes through black hole doorways, we might expect the fundamental constants of physics to vary over time as our universe exchanges material with others having different physical properties. The remarkable stability of physical constants over cosmic history suggests that if doorways exist, they are highly selective about what they allow to pass. In our next chapter, we'll explore what it might mean to live in such a connected multiverse, and how this possibility might change our understanding of our place in the cosmic order. Another gentle breath, in and out, like tide pools filling and emptying under starlight. Let your body settle deeper into rest as we approach one of the most profound mysteries lurking at the intersection of black holes and the possibility of other universes. The question of information, memory, and cosmic bookkeeping. The universe, it seems, is a careful librarian. Every interaction, every transformation, every quantum event appears to be recorded somewhere in the cosmic ledger, preserved according to laws that govern not just matter and energy, but the fundamental capacity for pattern, structure, and meaning to persist through time. Tonight, we'll explore how black holes might serve not just as doorways to other universes, but as cosmic libraries, archiving and transmitting the accumulated memory of existence itself. Begin with a simple but profound principle that governs all of physics: the conservation of information. In quantum mechanics, information cannot be created or destroyed, only transformed from one form to another. When you burn a book, the information contained in its pages is not lost but converted into the pattern of ash, smoke, and heat that results from the burning. In principle, if you could perfectly track every particle and energy state, you could reconstruct the original book from its scattered remains. This principle of information conservation works beautifully in most physical processes. When stars shine, when galaxies collide, when life evolves on planetary surfaces, information is transformed, but never truly lost. The cosmic library grows ever more complex, but no pages are ever torn out and discarded. Every moment of cosmic history is preserved somewhere in the vast pattern of matter and energy that makes up reality. But black holes present a puzzling challenge to this cosmic bookkeeping. When matter falls past the event horizon, it disappears from our ability to observe or interact with it. The information that defined that matter, its quantum states, its organizational patterns, its history, seems to vanish behind the veil of the horizon. If the black hole later evaporates through Hawking radiation, does that information disappear forever, or is it somehow preserved and transmitted elsewhere? This information paradox has haunted theoretical physics for decades. It represents a potential conflict between general relativity, which allows information to disappear behind event horizons, and quantum mechanics, which insists that information must always be conserved. The resolution of this paradox might hold the key to understanding whether black holes truly serve as doorways to other universes. One of the most elegant proposed solutions to this paradox emerges from the holographic principle, a deep insight from string theory and black hole physics. The holographic principle suggests that all the information contained within a volume of space can be encoded on its boundary surface. Just as a hologram can store a three-dimensional image on a two-dimensional surface, perhaps the three-dimensional interior of any region can be completely described by information stored on its two-dimensional boundary. For black holes, this principle has profound implications. All the information about matter that has fallen past the event horizon might be encoded on the horizon itself, stored in the subtle quantum patterns that define the horizon structure. The black hole becomes like a cosmic hard drive, preserving perfect records of everything that has ever crossed its threshold. But if information is stored on the horizon, how might it be transmitted to other universes? Here, the doorway hypothesis offers a beautiful possibility. Perhaps the event horizon is not just a storage medium, but a transmission interface, a cosmic rotor that encodes information about infalling matter and transmits it through higher dimensional channels to other universes. In this view, when matter crosses the event horizon, its information is not lost but archived and forwarded. The black hole serves as both library and post office, preserving the accumulated memory of our universe, while simultaneously sharing it with other cosmic realms through mechanisms we are only beginning to glimpse. The quantum entanglement structure of space-time provides another pathway for understanding how information might flow through black hole doorways. Recent advances in quantum gravity research suggest that the fabric of space-time itself might be woven from quantum entanglement, with distant regions connected by invisible threads of quantum correlation. These entanglement networks might provide the infrastructure through which information flows between universes. When matter falls into a black hole, its quantum information becomes entangled with the black hole's horizon. If the horizon is itself entangled with structures in other universes, then information could flow through these quantum channels like data transmitted through fiber optic cables. Picture the multiverse as a vast neural network, with black holes serving as synapses, connection points where information can jump from one cosmic realm to another. Each time matter crosses an event horizon, it triggers a quantum signal that propagates through the entanglement web, carrying information about our universe to distant cosmic neighbors, and perhaps receiving information in return. This quantum information exchange might help explain some of the mysteries of dark matter and dark energy. Perhaps dark matter represents information patterns transmitted from other universes, quantum shadows cast by the structure of distant cosmic realms. Perhaps dark energy reflects the computational energy required to maintain these vast information networks, the cosmic equivalent of the electricity needed to power the internet. The holographic principle also suggests that the universe might have a fundamental information capacity limit, determined by the area of its cosmic horizon rather than its volume. This limit would be unimaginably vast, roughly 10 to 120 bits of information for our observable universe, but finite nonetheless. If black holes serve as information channels to other universes, they might help manage this cosmic storage problem, offloading information to other realms when our universe approaches its capacity limits. Consider entropy, that measure of disorder and information content that always increases over time. The second law of thermodynamics tells us that entropy must always grow in isolated systems, leading eventually to a state of maximum disorder called heat death. But if our universe is not isolated, If it can exchange information with other universes through black hole doorways, then perhaps the inexorable growth of entropy can be managed, exported to other realms to maintain the possibility of order and complexity indefinitely. In this vision, black holes serve as cosmic waste management systems, not destroying information, but recycling it, sending it to other universes where it can contribute to new forms of complexity and organization. The death of stars in our universe becomes the raw material for new stars in other cosmic realms, ensuring that the capacity for beauty, complexity, and meaning never truly diminishes, but is constantly renewed through the patient work of black hole doorways. The mathematical structure of black hole thermodynamics supports this vision of cosmic information exchange. Black holes have temperature, entropy, and other thermodynamic properties, just like ordinary matter, but unlike ordinary matter, a black hole's entropy is proportional to its surface area rather than its volume. This suggests that the fundamental information storage and processing in black holes occurs at the boundary, at the event horizon itself. When black holes merge, their entropy increases in a very specific way that respects both quantum mechanics and general relativity. The final black hole always has entropy at least equal to the sum of the initial black hole's entropies. This entropy increase might reflect not just local physics, but the information bookkeeping required to maintain consistency across multiple universes connected through black hole doorways. The timescales involved in black hole information processing are almost incomprehensibly vast. A stellar mass black hole would take longer than 10 to 60 years to evaporate through Hawking radiation, a time so long that the current age of the universe is barely a whisper by comparison. During this vast span, the black hole would slowly process and potentially transmit all the information it has accumulated, particle by particle, bit by bit, through whatever cosmic networks connect our universe to others. But supermassive black holes, containing millions or billions of solar masses, would take even longer to evaporate, times approaching 10-100 years or more. These cosmic giants serve as nearly permanent archives, preserving the accumulated memory of entire galaxies for time spans that dwarf any normal conception of forever. If they serve as information channels to other universes, they represent the most stable and long-lasting communication infrastructure in the cosmos. This vast temporal scale suggests that the multiverse information network, if it exists, operates according to a patience that makes cosmic evolution seem hurried by comparison. Information flows between universes, not in the rapid bursts we associate with digital communication, but in slow, steady streams that persist for times longer than the entire history of stars and galaxies. Yet even this glacial pace might be appropriate for the kinds of information being transmitted. Perhaps what flows through black hole doorways is not detailed quantum data about individual particles, but deeper organizational principles, fundamental patterns that can guide the evolution of complexity in other cosmic realms. The information equivalent of DNA rather than detailed cellular structure, providing templates for cosmic evolution rather than specific blueprints. The concept of cosmic memory takes on new meaning in this context. If information flows freely between universes through black hole networks, then each universe carries within it traces of all the others. Our cosmic microwave background might contain subtle signals from other universes, transmitted through black hole channels and preserved in the statistical patterns of temperature fluctuations across the sky. Similarly, the fundamental constants of physics, the strength of gravity, the speed of light, the masses of particles, might be influenced by information exchange with other universes, rather than being arbitrary numbers set at the moment of cosmic birth. They might be dynamic quantities that slowly evolve as our universe exchanges information with cosmic neighbors through black hole doorways. This vision transforms our understanding of cosmic solitude. Rather than existing as isolated islands in an empty void, universes might be part of a vast archipelago, connected by invisible bridges that allow the patient exchange of information, memory, and meaning across unimaginable scales. We are not alone in existence, but part of a cosmic community whose conversations unfold over time, scales that make geological epochs seem like brief moments. Let your mind rest gently in this possibility. The universe is a vast library where no information is ever truly lost, where the memory of every event, every pattern, every moment of complexity is preserved and shared through networks of black hole doorways, where the local growth of entropy and approach of heat, death is balanced by the global circulation of information through cosmic channels that ensure renewal and rebirth across the multiverse. In our next chapter, we'll explore the implications of living in such an interconnected cosmos, and what it might mean for our understanding of meaning, purpose, and our place in the vast conversation of existence. Breathe slowly and let your awareness settle like mist in a quiet valley. We're about to explore the deepest mechanics of how black hole doorways might actually function, the quantum and relativistic processes that could allow matter, energy, and information to slip through the fabric of space-time from one universe to another. The journey from theoretical possibility to physical mechanism requires us to descend into the quantum realm, where the familiar concepts of particle and wave, here and there, now and then, begin to dissolve into something more fundamental and strange. At these scales, the universe reveals its most intimate secrets about the nature of space, time, and existence itself. Begin with quantum tunneling, one of the most counterintuitive but well-established phenomena in physics. In the everyday world, particles cannot pass through barriers that they don't have enough energy to overcome. A ball rolled gently toward a hill will stop and roll back if it doesn't have sufficient kinetic energy to reach the summit. But in the quantum realm, particles can tunnel through energy barriers, even when they lack the classical energy needed to surmount them. It's as if the ball could somehow pass through the hill rather than over it, emerging on the other side with the same energy it had initially. This quantum tunneling is not just a theoretical curiosity, it's the process that powers the sun, allows scanning tunneling microscopes to image individual atoms, and enables the electronic devices that surround us in daily life. The mathematics of quantum tunneling emerges from the wave nature of matter at small scales. Quantum particles are described not as point-like objects, but as probability waves that spread through space. When such a wave encounters a barrier, part of it reflects back while part continues forward, even if the particle's energy is less than the barrier height. The probability of finding the particle on the far side of the barrier is small but nigh. Now imagine scaling this quantum tunneling phenomenon up to cosmic proportions. If space-time itself has a quantum structure at the smallest scales, and most theories of quantum gravity suggest that it must, then perhaps large-scale objects like black holes can exhibit quantum behavior under the right circumstances. Perhaps the event horizon of a black hole is not an impermeable barrier, but a quantum tunnel through which matter and information can pass into other universes. The energy scales involved would be enormous, requiring the extreme gravitational fields present near black hole horizons to create the conditions necessary for cosmic-scale quantum tunneling. But the basic principle remains the same. The wave function describing the matter falling into the black hole would have a small but nigh probability of emerging in another universe, rather than reaching the singularity. This quantum tunneling interpretation of black hole doorways helps resolve the information paradox in an elegant way. Information doesn't disappear when it crosses the event horizon. It tunnels through to another universe, where it contributes to the complexity and structure of a different cosmic realm. The process preserves information conservation while allowing black holes to serve as one-way passages between universes. But quantum tunneling represents just one possible mechanism for cosmic passage. Einstein-Rosen bridges, those wormhole-like solutions to the equations of general relativity, provide another pathway. These mathematical structures describe tunnel-like connections through the higher dimensional fabric of space-time, creating shortcuts between distant regions or even between separate universes. The geometry of an Einstein-Rosen bridge is mind-bending in its implications. Imagine space-time as a two-dimensional surface, like a stretched rubber sheet. A black hole creates a deep depression in this surface, like a funnel carved into the rubber. In the Einstein-Rosen picture, this funnel doesn't end in a point, but connects to another funnel opening elsewhere, creating a tunnel through the higher dimensional space in which the rubber sheet is embedded. Matter falling into one mouth of this tunnel would emerge from the other mouth, potentially in a completely different region of space, or even in a different universe altogether. The journey through the tunnel might take place outside of normal space-time, through dimensions we cannot directly perceive, making the passage instantaneous from the perspective of three-dimensional observers. However, classical Einstein-Rosen bridges suffer from fatal instability. They collapse so quickly that nothing can pass through them. The tunnel pinches shut before any signal can traverse its length. This instability arises from the gravitational attraction of the bridge's own geometry, which pulls the tunnel walls together faster than light can cross from one mouth to the other. But quantum mechanics might provide a solution to this instability problem. The uncertainty principle tells us that empty space is never truly empty, but filled with virtual particle pairs that spontaneously appear and disappear. Near the extreme gravitational fields of black holes, these quantum fluctuations become amplified and can have measurable effects on the surrounding geometry. Some theoretical models suggest that these quantum effects might generate a form of negative energy density that could prop open Einstein-Rosen bridges, preventing them from collapsing and making them traversable. This negative energy would act like cosmic scaffolding, holding the tunnel open against its tendency to collapse and allowing matter and information to flow through from one universe to another. The required negative energy densities are extreme, involving physics far beyond our current experimental capabilities. But the universe has surprised us before with phenomena that seemed impossible until we discovered them. The cosmic acceleration driven by dark energy involves something very much like negative pressure, suggesting that the universe already employs exotic energy conditions that we don't fully understand. Another mechanism for cosmic passage emerges from string theory, the ambitious attempt to unify all forces and particles into a single theoretical framework. In string theory, black holes are not simple geometric objects, but complex dynamical systems composed of fundamental strings in highly excited states. These excited string configurations might have the ability to tunnel between different vacuum states, different ways of configuring the extra dimensions that string theory requires. If each vacuum state corresponds to a different universe with different physical properties, then black holes might serve as transition points where the universal wave function tunnels from one cosmic configuration to another. The process would be similar to quantum tunneling, but operating at the level of the universe's fundamental structure rather than individual particles. The black hole would serve as a catalyst, creating conditions where the fabric of reality itself can tunnel from one state to another, carrying matter and information along in the transition. This string theory picture suggests that black hole doorways might not just connect regions within a single multiverse, but actually create new universes by tunneling into previously unoccupied regions of the cosmic landscape. Each black hole formation event might represent not just the death of a star, but the birth of an entire new cosmic realm, complete with its own physics, particles, and possibilities for complexity. The topology of space-time provides yet another avenue for understanding cosmic passage. General relativity allows for exotic topological structures, spaces with unusual connectivity properties that permit shortcuts between distant regions. These structures, with names like baby universes and space-like wormholes, describe ways that space itself might branch and reconnect in patterns that create natural doorways between cosmic realms. A baby universe would be a small, self-contained region of space-time that buds off from our larger universe, like a soap bubble forming on the surface of a larger bubble. The connection point between the baby universe and the parent universe would appear from our perspective as a black hole, while observers in the baby universe would see it as their cosmic beginning. These topological structures don't require exotic matter or extreme quantum effects. They emerge naturally from the mathematical structure of general relativity itself. If they exist in nature, they would provide a mechanism for cosmic reproduction, allowing universes to give birth to new universes through black hole formation events. The timescales involved in these cosmic passage mechanisms vary dramatically. Quantum tunneling events would be essentially instantaneous from the perspective of outside observers, though the subjective experience of the tunneling matter might be quite different. Einstein-Rosen bridge transits would also be rapid, limited only by the speed of light and the geometry of the tunnel itself. But other mechanisms might involve much longer timescales. If black holes serve as slow information processors, gradually encoding and transmitting the data of infalling matter over millions or billions of years, then passage to other universes might be a gradual process rather than a sudden transition. The matter that falls into a black hole today might not emerge in another universe until long after our sun has died and our galaxy has merged with Andromeda. These vast timescales suggest that cosmic passage operates according to different principles than we normally associate with travel or communication. Rather than providing rapid transit between universes, Black hole doorways might serve as patient archives and slow distributors, preserving the memory of one universe while gradually seeding the growth of others over cosmic timescales. The energy requirements for these passage mechanisms are similarly varied. Quantum tunneling might occur naturally whenever the right conditions arise near black hole horizons, requiring no additional energy input beyond what's already present in the extreme gravitational fields. Einstein-Rosen bridges propped open by exotic matter would require enormous energies to create and maintain, far beyond anything we could produce artificially. But perhaps the most intriguing possibility is that cosmic passage requires no energy at all, that it represents a fundamental symmetry of space-time, a natural flow of information and complexity from regions of high organization to regions of lower organization. In this view, black holes would be like cosmic waterfalls, allowing the natural downhill flow of information from complex universes to simpler ones, driven by the same thermodynamic principles that govern all energy flows in physics. The directionality of cosmic passage raises fascinating questions about the relationship between different universes in the multiverse network. If information flows naturally from complex to simple universe, then our own universe might occupy a particular position in this cosmic hierarchy, perhaps as a mature, highly organized realm that is gradually sharing its accumulated complexity with younger, simpler universes through black hole doorways. Alternatively, the flow might be bidirectional, with information circulating through the multiverse network like currents in a vast ocean. Our universe would both give and receive, simultaneously seeding new cosmic realms while being enriched by information flowing from other universes through white hole emergence events that we might not yet know how to recognize. Let your imagination rest in the mechanics of passage, in the quantum tunnels and cosmic bridges that might connect our universe to others. Every black hole a doorway, every event horizon a membrane through which the substance of existence can flow from one cosmic realm to another, carrying with it the accumulated memory and complexity of entire universes. These mechanisms operate at the intersection of our deepest theoretical understanding and our most speculative imaginings. They push the boundaries of physics into realms where mathematics and poetry begin to converge, where the equations that describe reality become so strange and beautiful that they seem to demand new forms of language to express their implications. In our next chapter, we'll explore what it might mean to live in a universe connected to others through these cosmic doorways, and how this possibility might transform our understanding of existence, meaning, and our place in the vast conversation of the multiverse. Another gentle breath, slow and steady like the rhythm of distant waves. Let your body continue its journey into deeper rest as we explore perhaps the most profound question of all. If black holes truly are doorways to other universes, what does this mean for us, for our understanding of existence, purpose, and the significance of our small lives in an infinite web of cosmic possibilities? The possibility of living in a multiverse connected by black hole doorways transforms not just our scientific understanding, but our philosophical relationship with existence itself. It suggests that we are not isolated travelers on a cosmic island, but part of an infinite archipelago, connected through invisible bridges to realms we can barely imagine. Begin with the question of meaning in an interconnected cosmos. If our universe is one among countless others, all connected through the patient work of black hole doorways, does this make our lives more meaningful or less? The answer depends on how we choose to understand our place in this vast web of connection and exchange. One response might be to feel diminished by the scale of such a multiverse, to see our problems, achievements, and even our existence as vanishingly small against the backdrop of infinite cosmic realms. But this response misses the profound intimacy that black hole doorways create between universes. If matter, energy, and information flow freely between cosmic realms, then we are not isolated from the larger multiverse, but intimately connected to it. Every atom in your body might carry traces of other universes, quantum information that has tunneled through black hole doorways to contribute to the matter that forms your cells, your thoughts, your dreams. The carbon in your muscles might have been forged in stars in our universe, but the quantum patterns that organize that carbon into living tissue might carry influences from cosmic realms beyond our ability to observe directly. In this view, you are not just a local phenomenon in an isolated universe, but a convergence point for influences from across the multiverse. Your consciousness, your creativity, your capacity for wonder and love represent the flowering of patterns that might have their roots in the soil of countless cosmic realms, all connected through the invisible network of black hole doorways. This interconnection suggests a form of cosmic democracy that is both humbling and elevating. If every universe in the multiverse network contributes to the complexity and beauty of every other universe, then our small contributions to local complexity, our art, our science, our acts of compassion, become part of the larger conversation that flows through the cosmic web. When you create beauty, solve problems, or reduce suffering in your immediate environment, you are not just affecting your local space and time, but contributing to patterns that might eventually propagate through black hole doorways to influence the development of other cosmic realms. The kindness you show to a friend, the problem you solve at work, the moment of wonder you experience looking at a sunset, all of these become part of the accumulated complexity that our universe shares with others through the patient work of cosmic passage. This cosmic democracy also suggests that we are recipients as well as contributors. The insights that arise in human consciousness, the sudden solutions to long-standing problems, the unexpected moments of beauty and connection that punctuate our lives. Perhaps these represent the influence of other universes flowing into our cosmic realm through black hole networks. The history of human discovery and creativity takes on new dimensions when viewed through the lens of multiverse interconnection. Perhaps the greatest insights in science, art, and philosophy represent moments when the cosmic web of information exchange creates particularly rich convergences in human consciousness. The minds of Einstein, Mozart, Shakespeare, Marie Curie might have served as especially sensitive receivers for the subtle signals that flow through the multiverse network. This doesn't diminish the achievements of these remarkable individuals, but suggests that their genius represented a form of cosmic collaboration, their minds serving as focal points where influences from across the multiverse could converge and find expression in forms comprehensible to human understanding. They were not isolated creators but cosmic translators, giving local voice to patterns that emerged from the vast conversation flowing through the web of connected universes. The concept of legacy takes on new meaning in an interconnected multiverse. If information and complexity flow freely between cosmic realms, then nothing we create or accomplish is ever truly lost. The patterns of organization that represent human culture, knowledge, and wisdom become part of the cosmic heritage that our universe contributes to the larger multiverse network. Long after our sun dies and our galaxy disperses, long after the last black holes in our universe evaporate through Hawking radiation, the patterns that represent human achievement will continue to exist in other cosmic realms, transmitted through the doorways that connect universe to universe across scales of time that dwarf any normal conception of permanence. But this cosmic legacy comes with cosmic responsibility. If our universe serves as a source of information and complexity for other cosmic realms, then how we develop and use that complexity matters not just locally, but universally. The choices we make about how to organize our societies, how to treat one another, how to develop our technologies and explore our cosmos, all of these become contributions to the larger conversation that flows through the multiverse network. This suggests an ethics of cosmic citizenship that extends far beyond our usual moral frameworks. We are responsible not just to our immediate communities and future generations in our own universe, but to the countless beings in other cosmic realms who might be influenced by the patterns of complexity that flow from our universe through black hole doorways. The development of artificial intelligence, the exploration of space, the preservation of biological diversity, the cultivation of wisdom and compassion, all of these local projects become part of our cosmic contribution to the multiverse network. We are gardeners tending not just our local cosmic plot, but contributing to the health and beauty of the infinite garden that connects all possible worlds. The search for extraterrestrial intelligence also takes on new dimensions in an interconnected multiverse. If other civilizations exist in our universe, they too would be contributors to and recipients of the information flowing through the cosmic web. Contact with such civilizations would represent not just local communication, but participation in a conversation that extends across the entire multiverse network. Perhaps the messages we should be sending and listening for are not just electromagnetic signals between civilizations in our own universe, but contributions to the larger patterns of complexity that flow through black hole doorways. The art, science, and wisdom of human civilization might already be part of a cosmic conversation whose other participants exist in universes we cannot directly observe. The question of consciousness itself becomes more profound in this context. If black hole doorways allow the free flow of information between universes, then perhaps consciousness represents a form of cosmic organization that can transcend the boundaries between cosmic realms. The subjective experience of being aware, of having inner experience, might be a pattern that propagates through the multiverse network, finding expression in countless forms across infinite cosmic realms. This suggests that consciousness is not just a local accident of biological evolution in our particular universe, but a fundamental aspect of cosmic organization, a pattern that emerges naturally when information reaches sufficient complexity and integration. Every conscious being becomes a unique perspective on the vast conversation that flows through the multiverse web, a local manifestation of the cosmic awareness that might pervade all connected realms. The role of science and exploration becomes a form of cosmic archaeology, attempting to decode the subtle traces of other universes that might be detectable in our local cosmic environment. Every astronomical observation, every particle physics experiment, every investigation into the fundamental nature of reality might reveal new aspects of our connection to the larger multiverse network. The patterns we observe in the cosmic microwave background, the distribution of dark matter, the behavior of quantum systems, the fundamental constants of physics, all of these might carry information about our universe's relationship to others in the cosmic web. Science becomes not just an exploration of our local cosmic environment, but a form of cosmic communication, a way of participating consciously in the conversation that flows through the multiverse network. This doesn't offer false comfort about personal immortality, but it does suggest that the patterns of organization that represent our lives and relationships become part of something larger and more enduring than any individual existence. We live not as isolated beings, but as temporary convergences of cosmic patterns that extend far beyond our particular space and time. The cultivation of wisdom, compassion, and beauty becomes not just personal development, but cosmic gardening, contributing to the health and richness of the entire multiverse network. Every moment of understanding we achieve, every act of kindness we perform, every instance of beauty we create or appreciate becomes part of the accumulated complexity that our universe shares with others through the patient work of black hole doorways. Let your mind rest gently in this vision of cosmic interconnection and responsibility. You are not an isolated observer of a distant universe, but an active participant in a conversation that spans all possible worlds. Your thoughts, your actions, your very existence represent unique contributions to a cosmic web of meaning that extends beyond imagination. In our final chapter, we'll gather together all the threads of our exploration and consider how this understanding of black holes as doorways might shape our future relationship with the cosmos and with each other. One last slow breath, deep and peaceful, as we approach the horizon of our journey together. Let your body rest completely now, surrendering to the gentle pull of approaching sleep as we explore the ultimate implications of living in a multiverse connected by black hole doorways. What this means for the future of consciousness, complexity, and the eternal dance of cosmic evolution. If black holes truly serve as doorways between universes, then the story of cosmic evolution becomes not a tale of inevitable decline toward heat death, but an epic of eternal renewal and transformation. The universe we inhabit becomes part of an infinite recycling system, where the death of stars in one cosmic realm provides the seeds for new creation in another, ensuring that complexity, beauty, and awareness never truly end, but are constantly reborn in new forms. Consider first the traditional picture of cosmic destiny. In an isolated universe, the second law of thermodynamics appears to lead inexorably toward a state of maximum entropy called heat death, a future state where all energy is evenly distributed, all temperatures equalized, and no further work can be extracted from the system. In this bleak vision, the stars eventually burn out, black holes slowly evaporate, and the universe approaches a state of perfect, lifeless equilibrium. But the possibility of black hole doorways transforms this narrative entirely. If our universe is connected to others through cosmic passage mechanisms, then entropy and complexity can be exchanged between realms. The heat death of our universe becomes not an ending, but a phase transition, a metamorphosis that allows the accumulated complexity of our cosmic realm to be transmitted to other universes, while we receive fresh inputs of low-entropy energy from cosmic neighbors. This cosmic recycling operates on timescales that dwarf normal conception. The transfer of complexity between universes through black hole doorways might take trillions of years to complete, operating so slowly that entire galaxies could evolve, merge and dissolve during what represents a brief moment in the larger conversation between cosmic realms. But the patience of this process is also its profound beauty. Like a vast cosmic breath that takes eons to inhale and exhale, the multiverse network ensures that no achievement, no moment of beauty, no flash of consciousness is ever truly lost, but becomes part of an eternal circulation of complexity and meaning across infinite scales of space and time. The role of conscious beings in this cosmic circulation becomes particularly significant. If consciousness represents a high form of cosmic organization, complex patterns of information integration that emerge when matter and energy reach sufficient sophistication, then conscious beings like ourselves might serve as crucial nodes in the multiverse network. Our capacity for awareness, creativity, and understanding might represent the universe's way of becoming conscious of itself and its connections to other cosmic realms. Through our science, we decode the subtle signals that flow through the cosmic web. Through our art, we give expression to patterns that might have origins in other universes. Through our compassion, we nurture the kinds of complexity that the multiverse network seems designed to propagate and preserve. In this vision, the evolution of consciousness is not just a local biological accident, but part of the universe's fundamental tendency toward greater complexity and self-awareness. Every thinking being becomes a unique perspective through which the cosmic web can observe and understand itself, a local manifestation of the vast intelligence that emerges from the interaction of countless cosmic realms. This suggests that the future evolution of consciousness in our universe is not limited by local resources and constraints, but connected to a vast reservoir of complexity flowing through the multiverse network. The development of artificial intelligence, the potential for genetic enhancement, the possibility of uploading consciousness to more durable substrates, all of these become not just local technological achievements, but contributions to the cosmic conversation that flows through black hole doorways. Future conscious beings, whether biological, artificial, or hybrid forms we cannot yet imagine, would serve as increasingly sophisticated interfaces with the multiverse network. They might develop the ability to consciously participate in the information exchange between cosmic realms, serving as active agents in the cosmic circulation of complexity and meaning. Imagine civilizations millions of years in the future that have learned to decode the subtle signals flowing from other universes through black hole doorways, that have developed technologies for encoding their own contributions to the cosmic conversation, that can consciously participate in the vast network of information exchange that connects all possible worlds. Such civilizations would represent the universe's flowering into full self-awareness and cosmic citizenship. The exploration of space takes on entirely new dimensions in this context. If black holes serve as doorways to other universes, then the investigation of black holes becomes not just astrophysics, but cosmic archaeology, an attempt to understand our universe's connections to the larger multiverse network. Every measurement of a black hole's properties, every observation of matter falling past an event horizon, becomes part of our effort to understand the cosmic conversation of which we are part. Future spacefaring civilizations might develop the technology to approach black holes safely, to study their doorway properties directly, perhaps even to influence the information exchange processes that flow between cosmic realms. They might become active gardeners of the cosmic web, nurturing the health and complexity of the multiverse network through conscious participation in its information circulation. The possibility of creating artificial black holes, if it ever becomes technologically feasible, would represent the ultimate expression of cosmic citizenship, the ability to create new doorways in the multiverse network, new channels through which complexity and meaning can flow between cosmic realms. Such technology would make conscious beings active participants in cosmic evolution rather than passive observers of natural processes. But even without such dramatic technological capabilities, our current scientific and cultural development represents a form of unconscious participation in the cosmic conversation. Every advancement in human knowledge, every achievement in art and literature, every expansion of compassion and wisdom becomes part of the complexity that our universe contributes to the multiverse network through the natural operation of black hole doorways. This vision also transforms our understanding of cosmic responsibility and stewardship. If our universe serves as a source of complexity for other cosmic realms, then how we develop and use our local resources affects not just our immediate cosmic neighborhood, but the entire multiverse network. Climate change, biodiversity loss, nuclear war, artificial intelligence risks, all of these challenges become not just local problems, but cosmic responsibilities. The patterns of organization that represent sustainable civilization, wise technology use, and harmonious relationships between conscious beings become part of our contribution to the cosmic conversation. Future civilizations in other universes might be influenced by the examples we set for how conscious beings can organize themselves and their relationships with their cosmic environment. Conversely, if we fail to develop sustainable and wise patterns of organization, if our civilization destroys itself through short-sighted choices, then this failure also becomes part of what our universe contributes to the multiverse network. The cosmic web would carry not just our achievements but also our mistakes, our failures, our missed opportunities for greater wisdom and compassion. This cosmic perspective suggests an ethics that extends far beyond traditional moral frameworks. We are responsible not just to our immediate communities and future generations, but to the countless beings in other cosmic realms who might be influenced by the patterns of complexity flowing from our universe. Every choice becomes a contribution to the vast conversation that connects all possible worlds. The question of ultimate meaning and purpose resolves itself naturally in this cosmic context. If consciousness and complexity are features that the multiverse network seems designed to propagate and preserve, then our existence as conscious beings represents our participation in the universe's fundamental purpose. We are not accidents in a meaningless cosmos, but expressions of the cosmic web's tendency toward greater awareness, understanding, and beauty. The meaning of our lives lies not in isolation, but in connection to each other, to our cosmic environment, and through the patient work of black hole doorways, to the infinite community of beings and worlds that populate the multiverse network. We find purpose not by transcending our cosmic context, but by embracing our role as conscious participants in the vast conversation of existence. Even the process of individual death becomes part of this larger cosmic purpose. If the patterns of organization that represent our consciousness contribute to the complexity that flows through the multiverse network, then our deaths are not endings but transformations, dissolutions that allow our accumulated experiences and insights to be incorporated into the vast library of cosmic memory. This doesn't offer false promises of personal survival or individual immortality, but it does suggest that the patterns of meaning we create during our lives become part of something larger and more enduring than any single existence. We live as temporary convergences of cosmic information, unique perspectives that emerge briefly from the vast conversation flowing through the multiverse network and then dissolve back into the larger pattern, leaving traces that influence future convergences in ways we cannot predict or control. The scientific investigation of black hole doorways becomes, in this context, humanity's first conscious attempt to understand and participate in the cosmic conversation of which we have always been part. Every advance in our understanding of black holes, quantum mechanics, and the fundamental structure of space-time brings us closer to conscious participation in the multiverse network that connects all possible worlds. Future discoveries might reveal the subtle signatures of other universes in our local cosmic environment. Perhaps we will learn to detect the faint traces of information flowing through black hole doorways, to decode the messages embedded in the cosmic microwave background radiation, to recognize the fingerprints of other cosmic realms in the statistical patterns of quantum events. Such discoveries would mark humanity's graduation from unconscious participants in the cosmic web to conscious cosmic citizens, beings who understand their role in the vast circulation of complexity and meaning that flows between universes. We would become active gardeners of the cosmic conversation, nurturing the kinds of complexity that enrich the entire multiverse network. The implications extend even to our most practical daily concerns. If every pattern of organization we create contributes to the cosmic conversation, then the quality of our relationships, the wisdom of our social institutions, the sustainability of our technology, the depth of our cultural achievements, all of these become forms of cosmic service, ways of contributing to the health and beauty of the entire multiverse network. This perspective doesn't diminish the importance of local concerns, but places them in a cosmic context that amplifies their significance. The kindness we show to a neighbor, the problem we solve at work, the beauty we create or appreciate, all of these become part of our contribution to a conversation that spans all possible worlds. The future of consciousness in a multiverse connected by black hole doorways is not limited by the resources of any single cosmic realm, but enriched by the infinite diversity of all connected universes. As we develop greater capacity for awareness, understanding, and creativity, we become more effective participants in the cosmic circulation of complexity and meaning. This vision suggests that the ultimate destiny of conscious beings is not individual transcendence or escape from the material world, but ever deeper participation in the cosmic web of relationship and exchange that connects all existence. We are called not to rise above the cosmos, but to dive more deeply into our role as conscious expressions of the universe's tendency toward greater complexity, beauty, and awareness. Let your breathing continue to slow and deepen as we approach the careful work of distinguishing between what we know, what we suspect, and what we can only dream about regarding black holes as doorways to other universes. This is where science shows its most beautiful face, not as a source of certainty, but as a method for holding uncertainty with grace and precision. The honest truth is that the doorway hypothesis remains largely speculative, existing more in the realm of theoretical possibility than established fact. But speculation in science is not mere fantasy. It is disciplined imagination constrained by mathematical consistency and guided by the patterns we observe in nature. The question is not whether we can prove that black holes are doorways, but whether this possibility deserves our serious consideration and continued investigation. Let's begin with what we know, with high confidence. We know that black holes exist. The gravitational wave detections from LIGO and Virgo have given us direct evidence of black hole mergers, while the Event Horizon Telescope has provided our first direct images of black hole shadows. We know that general relativity describes their properties with remarkable accuracy, predicting phenomena that we then observe with precision. We know that black holes have thermodynamic properties, temperature, entropy, and other characteristics usually associated with matter rather than empty space. We know that quantum mechanics predicts they should evaporate through Hawking radiation, though this process is so slow for large black holes that it remains unobserved. We know that the information paradox represents a genuine puzzle in our understanding of how quantum mechanics and general relativity fit together. We know that the universe appears to be part of a larger structure, the cosmic web of dark matter filaments that connects galaxies across vast scales. We know that space and time are not absolute, but relative, that they can be curved and twisted by mass and energy in ways our intuition finds difficult to grasp. We know that quantum mechanics allows for phenomena like tunneling and entanglement that seem to transcend normal spatial boundaries. These established facts provide the solid foundation upon which the doorway hypothesis rests. They tell us that the universe is stranger and more interconnected than everyday experience suggests, that the boundaries between here and there, now and then, possible and impossible, are more fluid than we might expect. But the leap from these established facts to the possibility of black hole doorways requires us to venture into more speculative territory. The mathematical solutions that describe wormholes and Einstein-Rosen bridges are valid within general relativity, but they require exotic conditions, negative energy densities, unusual matter properties that we have never observed and may not exist in nature. The quantum mechanics of black hole interiors remains largely theoretical, pushing our understanding to the limits, where different theoretical approaches give different predictions. String theory suggests possibilities for cosmic doorways, but string theory itself remains unproven, a mathematical framework so rich and complex that we have not yet found ways to test its key predictions. The holographic principle offers elegant solutions to the information paradox, but it too remains a theoretical proposal rather than an established fact. The idea that all the information in a volume of space can be encoded on its boundary surface is mathematically beautiful and consistent with many things we know, but it has not been directly verified in the context of black holes. So where does this leave us? The doorway hypothesis occupies that fascinating territory where rigorous mathematics meets unbounded imagination, where the equations that describe reality become so strange that they seem to demand new forms of poetry to express their implications. It is speculative in the best sense, grounded in established physics, but reaching toward possibilities that could transform our understanding of existence itself. The evidence for multiverse theories is similarly mixed. The many worlds interpretation of quantum mechanics is mathematically consistent and resolves certain paradoxes in quantum theory, but it makes no testable predictions that distinguish it from other interpretations. Eternal inflation provides a natural explanation for many features of our observable universe, but the other universes it predicts are by definition beyond our ability to observe directly. The cosmic microwave background radiation does show subtle anomalies that some theorists have suggested could be evidence of collisions with other universes or traces of our universe's exotic birth. But these same anomalies might have more conventional explanations, statistical flukes in the cosmic lottery that produced our particular cosmic initial conditions, the distribution of dark matter, the values of fundamental constants, the apparent fine-tuning of physics for the existence of complexity and life. All of these phenomena are consistent with multiverse theories, but none of them requires multiverse explanations. The universe might be finely tuned by design, by chance, or by physical principles we don't yet understand. This is where scientific humility becomes essential. The doorway hypothesis is not proven, but it is also not disproven. It remains a possibility worth exploring, investigating and refining as our understanding of fundamental physics continues to develop. It deserves neither uncritical acceptance nor dismissive rejection, but careful, ongoing consideration as we gather new evidence and develop better theoretical tools. The beauty of the hypothesis lies partly in its testability, at least in principle. If black holes truly serve as doorways to other universes, this should leave detectable traces in phenomena we can observe. The gravitational wave signals from black hole mergers might carry subtle signatures of information exchange with other universes. The cosmic microwave background might preserve fossil evidence of our universe's exotic birth. The statistical properties of quantum events might reflect the influence of other cosmic realms. These signatures would be incredibly subtle, requiring advances in both theoretical understanding and experimental precision to detect, but they represent genuine predictions that could, in principle, be tested as our technology and understanding continue to advance. The doorway hypothesis is speculative, but it is not empty speculation. It is disciplined imagination that makes contact with observable reality. The investigation of these possibilities requires what we might call gentle science, research that combines mathematical rigor with imaginative openness, that takes theoretical possibilities seriously, while maintaining appropriate skepticism about unproven claims. It requires scientists who are willing to explore strange ideas without losing their commitment to evidence and logical consistency. This gentle science is already underway in research groups around the world, in theoretical investigations that push the boundaries of our understanding, in observational programs that search for subtle signals that might reveal new aspects of cosmic reality. The work proceeds slowly, carefully, with full awareness that most speculative ideas in physics eventually prove to be wrong, but with recognition that the few that prove correct can transform our understanding entirely. The search for evidence of black hole doorways represents one of the most ambitious programs in contemporary physics, an attempt to test ideas that reach to the very foundations of reality itself. It requires the development of new mathematical techniques, new experimental approaches, new ways of thinking about the relationship between theory and observation. But perhaps most importantly, it requires a particular attitude toward the unknown, not fearful rejection of possibilities that challenge our current understanding, but patient openness to discoveries that might revolutionize our conception of existence itself. It requires the humility to acknowledge that our current theories, successful as they are, might be incomplete in ways we cannot yet imagine. The doorway hypothesis also exemplifies the way that speculative science can serve important philosophical and psychological functions even before it is proven or disproven. By seriously considering the possibility that our universe is connected to others through black hole doorways, we are forced to confront fundamental questions about the nature of existence, meaning, and our place in the cosmic order. These questions have practical implications for how we think about cosmic responsibility, environmental stewardship, the development of artificial intelligence, and the search for extraterrestrial life. If our universe is part of a larger multiverse network, then our local actions have cosmic consequences that extend far beyond our immediate space and time. The doorway hypothesis also offers a form of comfort in the face of cosmic solitude and meaninglessness. If we are connected to other universes through invisible channels, if our local achievements contribute to a larger cosmic conversation, then we are neither alone nor insignificant in the vast scheme of existence. But this comfort must be balanced with intellectual honesty. The hypothesis remains unproven, and it is possible that future discoveries will show it to be incorrect. The universe might be exactly what it appears, a single, isolated cosmic realm where black holes are endings rather than doorways, where death is final, and cosmic heat, death is inevitable. Science requires us to hold both possibilities simultaneously, the magnificent vision of cosmic interconnection and the starker possibility of cosmic isolation. Without premature commitment to either, this is perhaps the most difficult intellectual discipline that science demands. The ability to live with uncertainty while continuing to investigate, to remain open to transformation while maintaining appropriate skepticism. The doorway hypothesis represents science at its most ambitious and most humble, reaching toward possibilities that could revolutionize our understanding while acknowledging the limits of current knowledge. It embodies the scientific spirit at its best, rigorous but not rigid, imaginative but not fantastic, skeptical but not cynical. As we continue this investigation, we carry with us both the excitement of potential discovery and the acceptance of possible disappointment. We pursue the evidence wherever it leads, prepared to abandon beautiful ideas if they prove inconsistent with reality, but equally prepared to embrace revolutionary possibilities if the evidence supports them. One final, slow breath as our journey together approaches its gentle end. Let your body rest completely now, surrendering to whatever form of peace the night offers. As we gather together the threads of wonder we have followed through the possibility that black holes might be doorways to other universes. We began this exploration with a simple question whispered in the darkness. Could the most mysterious objects in our universe, those regions where space and time curve so deeply that even light cannot escape, actually serve as passages to entirely different cosmic realms? Along the way, we have wandered through the elegant architecture of black holes, explored the infinite garden of the multiverse, examined the quantum tunnels and cosmic bridges that might allow passage between worlds, and considered what it might mean to live in such an interconnected cosmos. The honest answer to our original question is that we don't yet know. The doorway hypothesis remains in that fascinating territory where rigorous mathematics meets unbounded imagination, where theoretical possibility encounters the patient resistance of experimental verification. It is speculative in the best sense, grounded in established physics, but reaching toward possibilities that could transform our understanding of existence itself. But perhaps the most important discovery of our journey is that the question itself transforms us in the asking. To seriously consider whether black holes are doorways to other universes is to open our minds to possibilities that stretch our conception of reality, that challenge our assumptions about isolation and connection, meaning and purpose, life and death. We have seen how this possibility might resolve some of the deepest puzzles in physics: the information paradox, the fine-tuning problem, the nature of cosmic initial conditions. We have glimpsed how it might transform our understanding of consciousness, complexity, and the ultimate destiny of cosmic evolution. We have explored how it might place our local lives and achievements in a context of cosmic citizenship that extends across infinite scales of space and time. Whether or not black holes actually serve as doorways to other universes, the investigation of this possibility is already enriching our understanding of reality. It pushes us to develop new mathematical tools, new experimental approaches, new ways of thinking about the relationship between the very large and the very small, the local and the cosmic, the known and the unknowable. The doorway hypothesis also serves a profound psychological and philosophical function. In a universe that can often seem vast, cold, and indifferent to human concerns, it offers the possibility of connection, meaning, and cosmic purpose. It suggests that we might be part of something larger and more wonderful than we have yet imagined. participants in a cosmic conversation whose scope exceeds our wildest dreams. But this comfort comes with responsibility. If our universe is connected to others through black hole doorways, then how we develop our science, our technology, our social institutions, and our relationships with each other becomes a matter of cosmic significance. We are called to be good cosmic citizens, nurturing the kinds of complexity and wisdom that enrich not just our local cosmic neighborhood, but the entire multiverse network. The search for evidence of black hole doorways represents one of the most ambitious projects in contemporary science, an attempt to test ideas that reach to the very foundations of reality itself. This search requires not just new instruments and mathematical techniques, but new forms of intellectual courage, the willingness to take seriously possibilities that challenge our most basic assumptions about the nature of existence. It also requires a particular kind of humility, the recognition that our current understanding, impressive as it is, might be incomplete in ways we cannot yet imagine. The universe has surprised us before with phenomena that seemed impossible until we discovered them. Dark matter, dark energy, quantum entanglement, gravitational waves. All of these were once considered exotic speculation before becoming established fact. Perhaps black hole doorways will join this list of impossible possibilities that prove to be real. Perhaps future generations will look back on our current ignorance of multiverse connections the way we now look back on pre-Copernican astronomy or pre-quantum physics, as a necessary stage in the long journey toward deeper understanding. Or perhaps the doorway hypothesis will prove to be one of those beautiful ideas that nature ultimately rejects, a mathematical possibility that doesn't find expression in physical reality. Science is littered with elegant theories that fail to match the stubborn facts of observation, and theoretical beauty is no guarantee of empirical truth. Either way, the investigation continues, driven by the same curiosity and wonder that have always motivated the best science. We follow the evidence wherever it leads, prepared to abandon cherished ideas if they prove inconsistent with reality, but equally prepared to embrace revolutionary possibilities if the evidence supports them. The doorway hypothesis reminds us that science at its best is not just about accumulating facts, but about expanding our conception of what might be possible. It pushes us to ask bigger questions, to imagine stranger possibilities, to remain open to discoveries that could transform our understanding entirely. In this sense, every black hole we observe becomes a doorway of a different kind, not necessarily a passage to other universes, but certainly a portal to deeper understanding. Each gravitational wave signal, each image from the Event Horizon Telescope, each theoretical breakthrough brings us closer to understanding these magnificent objects and their role in the cosmic order. Whether they prove to be endpoints or doorways, black holes have already transformed our understanding of space-time, gravity, and the fundamental structure of reality. They have pushed physics to its limits and beyond, forcing us to develop new mathematical tools and conceptual frameworks to understand their behavior. The investigation of black hole doorways continues this tradition of using extreme phenomena to probe the deepest principles of physics. It represents science at its most adventurous, reaching toward possibilities that could revolutionize our understanding of existence itself. As you drift towards sleep, perhaps carried by dreams of cosmic gardens and quantum bridges, of information flowing between universe-like songs shared between distant choirs, remember that you are already part of whatever cosmic conversation exists. Your consciousness, your creativity, your capacity for wonder and love represent remarkable achievements in the universe's long journey toward greater complexity and self-awareness. Whether that journey is confined to our single cosmic realm or extends across an infinite multiverse connected by black hole doorways, you are a unique and irreplaceable participant in the magnificent adventure of existence. The patterns of meaning you create, the relationships you nurture, the understanding you develop, all of these contribute to the universe's growing capacity for beauty, wisdom, and compassion. The doorway of wonder opens not just toward other universes, but toward new ways of understanding and participating in the cosmos we know we inhabit. Through that doorway, we glimpse possibilities that inspire our continuing investigation of the magnificent mystery of existence itself. Thank you for joining me on this gentle exploration through the darkest and most mysterious regions of space and time. If this journey has sparked your own sense of wonder about the cosmos and our place within it, then it has served its purpose, regardless of what future discoveries reveal about the reality of black hole doorways. The questions will remain here in the darkness, patient as distant stars, waiting for the next curious mind to approach them with appropriate mixture of rigor and imagination, skepticism and wonder. Until then, rest well in the knowledge that you are part of something larger and more wonderful than we have yet learned to imagine, and breathe, one last time, in the vast and mysterious night that connects us all.